Hey everyone, welcome to this video. We're talking about angles and radian measure. We're just kind of reviewing how to draw angles, and then we're going to talk about radians. Okay, radians is another way of measuring angles other than degrees. And in fact, degrees, well, after this class, you're never going to see degrees again. Sorry. It's all radian measure. Radian measure is just, honestly, I don't know why it's used more often. I think because radian measure, you have infinite numbers, whereas degrees, I don't know. Honestly, I don't know why they use radians over degrees. I know a lot of people feel like, or radians are more exacting, I guess you could say. We use pi because it comes from the circumference of a circle, and that's what our angles are based off of, our circumferences of circles. I think that's probably why, but I do know this, you're not going to see it again. So we might as well get used to radians. Everything's going to be in radians. Now, it's going to be tough. Okay, you can do it. I know you can. You're just going to have to put in a little extra effort because it is kind of a new thing. All right, but we are going to be using radians. I'm going to introduce it today, and we're going to use it from here on out. Okay. All right, let's see here. How to draw an angle again. So the definition of an angle is two rays from an original vertex or an origin location, right? So an array is a line where one side, like one part of the line, has it stops at a point. Okay, so this is an angle. Okay, now when drawing an angle, you start with an initial side. Okay, so an initial ray, and then you raise the angle, or you rotate the angle to the desired location. Okay, so that's how you would write an angle, right? So I took my second side and I rotated it. This is called the initial side, initial. This is called the terminal side, okay, or ending side, right? It's the terminal side. That's where it ends. If I rotate my angle, if I rotate my terminal side, counterclockwise is positive. It's a positive angle. If I rotate it clockwise, then it's a negative angle. It has a negative angle measure. Okay, so counterclockwise this way is a positive angle. And then clockwise, this way, is a negative angle measure. Okay. Now, when we draw angles, for example, on a coordinate plane, that's what we'll end up doing most of our angle drawing. The initial side is always the positive x-axis. So here's my origin. The positive x-axis is this side. Okay, for our purposes, now this obviously can change, but for our purposes only, the initial side is our positive x-axis. So on our practice drawing, if I had 240 degrees, hold up, we should probably review the angle measures, right, of our coordinate plane. So think of 360 degrees, right? If you're doing a trick and you do a 360, you turn all the way around, boom, and you land back facing where you were at the beginning. Right, it's a full circle, 360 degrees full circle. So, if I have a coordinate plane and I go the full circle, this is 360 degrees. If I don't have an angle, it's also 0 degrees, right? All right, now if I only go a half circle, right, that's half of 360. So you take 360 and you divide it by 2. Oh, 180 degrees. Let me use a different color. So from the initial side, and we go half a circle, that's 180 degrees. Okay. Now, what's half of 180? Well, it's not half a circle. It's just like a right angle, right? Well, you know what a right angle is, right? This right here is a right angle. It's 90 degrees. which makes sense, right? If all the way around the quadrant, so if I have my coordinate plane again, all the way around is 360, and I have 4 quadrants or 4 squares. Well, what's 360 divided by 4? 360 divided by 4 is 90. So each one of these squares is 90 degrees. Okay. Now a reminder, there's names for these quadrants. Okay, this first one, so the top right-hand side is quadrant 1. Okay, they get their names from the angles. So if we start on the positive x-axis, the first quadrant we go through is this one right here, 1. And then we go on to the second one, top left-hand side. And then we rotate down to the third one. So bottom left-hand side. And then we rotate to the last one, or the fourth one, which is the bottom right-hand side. So these are also the quadrant names. Okay, that's something you've been told before. Just quick review. So let's practice some drawing some angles. So 240 degrees. Here's my quadrant plane. My initial side is the positive x-axis. It's positive, so I'm going to rotate counterclockwise. And I need 240 degrees. Okay, well, from here to here is 90 degrees. And then we do another one, that's another 90. So that's 180. If I want another 90, it would be 270. But I want 240, so not quite 270. So I'm not going to go to the next line here. I'm going to go just before it, about right there. And then I'm going to draw my arrow here, showing the direction that I'm turning. Because I'm going counterclockwise, it shows that it's a positive angle. Okay, and it's 240 degrees. Okay, let's do 80 degrees. So we have 80 degrees. Okay, my initial side is the positive x-axis. Now, from here to the first line, right, this first quadrant is 90 degrees. But I don't want quite 90, right? I want 80, I want a little less. So I'm not going to go quite until that line. I'm going to go just a little bit less. It's a positive angle, so I'm drawing counterclockwise. That's why this angle is here. I label it as 80 degrees. Okay, let's see, and then we have 500. Degrees. Well, all the way around is 360. So I'm going to go all the way around. But I haven't hit 500 yet, right? I need to know how much more we need to go. So 500 minus 360. What is that? 0. I need another 140 degrees. Well, I went all the way around once, and then if I go to this through this first quadrant again, I have another 90. So I need 50 more degrees. So not quite 90, so not down to this other one, the negative x-axis, just before it. So about right there. A little bit more. Okay, it's a positive angle, so we went counterclockwise. Here's your terminal side. Initial side, 500 degrees. Let's do negative 50. Oops, negative 50 degrees. Okay, so our initial side is the positive x-axis. Now negative, we're going clockwise. We're going this direction. I need to go 50 degrees. Well, if I go down to this other line, the negative y-axis, it's actually negative 90 degrees, right? Because that one quadrant is 90 degrees. So I don't want to go quite to 90, so it's about right there. And I'm going clockwise, so I draw my arrow going clockwise, and that's your angle. All right. Another type of angle we need to talk about is something called a coterminal angle. So coterminal angles, they share terminal sides. Okay. So if I have an angle here, like that, this is the initial, this is the terminal. I could have another angle that goes all the way around once and then comes back to that same side. I could also have an angle, let's say, here's my initial, that goes like this. I could go all the way around this way, a negative angle, and come back and still have the same terminal side. As long as your angle ends on the same side as another angle, they're called coterminal angles. A nice little pattern is that coterminal angles are just increments of 360 degrees, okay, negative or positive, right? Because to find another angle that ends at exactly the same place, you have to go around the circle again, right? Or go backwards around the circle to get back to the same place. So we're going to use that pattern here. Okay, I'll do this first one with a picture, and I'll do the other ones just using algebra. So 90 degrees. So coordinate plane, here's the initial side. 90 degrees is to the positive y-axis. Okay, so here's the terminal side. Here's the initial side. Okay, do you see that? Yeah. So if I want to find a different angle that has the same terminal side, well, I could go this way. Right, that's a negative angle, and the question it asks us is to find a positive and one positive, one negative coterminal angle. Well, if I go this direction, it's negative. And all I have to do, if the whole circle is 360, I take away the 90 and I know the other part. So 360 minus 90 is 270. Okay, but we went clockwise, so it's negative 270 degrees. And how about a positive one? Well, I have to start here initial, keep going around. I can't do that because that's still the same, that's a 90 degree angle, and we want a different one that's positive, so we just go around again. And we get back to where we stopped, or to our terminal side. Now I went around one time, and then I went another 90 degrees to get back to my terminal side, which is what? 450 degrees, and it's positive. Okay. Now notice what I did is all I had to do was I subtracted 360 degrees from 90 to get my negative. Subtraction, negative, right? And I added 360 degrees to get my positive. And that's really the algebra you need to do. So let's do 330 degrees. (330 degrees), a negative one. I subtract 360. So 330 minus 360, negative 30 degrees. That's a coterminal angle. That's negative. A positive one, 330 plus 360. What is that? 690 degrees. Well, there's your positive coterminal. And that's it. Let's do negative 135. Negative 135 degrees. Right, so find another negative one. Subtract 360. That is 495 degrees. Negative 495 degrees. So there's another negative. If I want to find a positive coterminal angle, you add 360, which is that ends in a 5, 225 degrees. Okay, let's do this last one, 740. So negative 740. There's two different ways you could do this. Now, if you think about it, there's infinite coterminal angles because you just keep going around the circle, right? So there's infinite. So if you want, well, we'll get there. To find the negative, we're going to subtract 360, which is what? 0, 0, 1,011, negative 1,011 degrees. Now let's find the positive. We're going to add 360. If I add 360, I get 0, 8, negative 380. Whoa, but I need a positive angle. Well, I got to go around the circle again. So I take negative 380, and I add 360. I get negative 20. Well, not quite positive yet, right? So I got to add another 360. I got to go around the circle again. So that is positive 340 degrees. Now, any of these negative angles here could have been your negative coterminal angle. So you could have added 360 and got negative 380 as a coterminal. You could have added 720, which is 360, 360, and got negative 20 as a coterminal negative angle, right? That's why I was saying that if you just keep going around the circle, right, you get infinite answers. Right? You can see you got three different answers. And if you just keep subtracting 360 from this for forever, you keep getting coterminal angles because you're just going around the circle again. All right. Now the fun part, radians. Okay, so here's a circle. Obviously not perfect. Here's the center. I'm going to have an angle here. Okay. The radius of the circle is 1. So 1, whatever unit you want, we're just going to say 1. Okay. The definition of a radian is the angle formed when the radius and the arc length are equal to each other. So when the radius is equal to this arc length, that's considered, that angle measure, or that angle that's created is considered 1 radian. Okay, when the arc length is equal to the radius. Sorry, I'm so tired. Okay. The circumference of a circle, the definition, or I guess the formula, is 2 pi r. Well, if I know the radius is 1, 2 pi times 1 is 2 pi. The entire circle has 2 pi radians. So 360 degrees is equal to 2 pi radians. Now remember, radians is not a distance, it's an angle measure. It's the same thing as degrees, but using the definition of the circumference rather than just some number we decided. All right? Well, we didn't just decide on it. I'm pretty sure there's a way we calculated it. Can't think of it right now. Like I said, I'm really tired. So, anyways, there's 2 pi radians in every circle. Okay. Let's see what else. Oh, okay. Now, if I divide 360 by 2, I get 180 degrees. Well, 180 degrees, if I divide 2 pi by 2, 2 divided by 2 is 1, so just 1 pi, or pi. Okay, so on our coordinate plane, all the way around is 2 pi, and just to the other side is pi. Now, if you want to figure out what 90 degree is, well, 180 divided by 2 is 90, so pi divided by 2 radians, or pi over 2. Okay. Looks like it. I'm gonna show a couple other very, very similar ones, or very important ones that we're gonna use. 30 degrees. Well, 30 is just 90 divided by 2. So 30 degrees, or excuse me, divided by 3. 30 degrees is pi over 2 divided by 3, which is pi over 2 times 1/3, which is pi over 6. Okay, I recommend you start committing these to memory. 360 is 2 pi. 180 is pi. 90 is pi over 2. 30 degrees is pi over 6. 60 degrees. Well, 60 degrees is 90 times 2/3, right? So 90 times 2/3 is 60. So if I take pi over 2 times 2/3, I get, these reduce, pi over 3. So 60 degrees is pi over 3. How about 270 is another big one. Well, 270 is 90 times 3. So it's pi over 2 times 3, which is 3 pi over 2. Another big one is 45 degrees. Now 45 degrees is half of 90. So this is pi over 2 divided by 2, which is pi over 2 times 1/2, which is pi over 4. Okay, these are exact values for angles, for very special angles. Okay, well we're going to be using these the rest of the quarter. So I'm going to rewrite them here. You can start committing these to memory, but I'm going to show you how to convert from radians to degrees and from degrees to radians. So I'll put a little chart here for you. 0 degrees is obviously 0 radians because you don't have an angle. 90 degrees is pi over 2. 180 is pi. 270, 3 pi over 2. 360, 2 pi. 30 degrees, pi over 6. 60 degrees, pi over 3. 45 degrees, pi over 4. Okay, these ones you really want to commit to memory. These ones you can get, right? 180 is just 2 90s. So pi over 2 and pi over 2, it's just 2 pi over 2, right? There's 2 of them. 2 pi over 2 is just pi, right? The 2's reduced. And then 3 of them, 3 pi over 2 is 270. And then 4 90s is 360, so it's 4 pi over 2, which 4 divided by 2 is just 2, so 2 pi. Okay. Now, we just established that pi is equal to 180 degrees, right? Sorry. So that means if I do 180 degrees divided by pi radians, that should equal 1 because they're the same, right? Anything divided by itself is 1. Okay, let's use that. Let's convert. We'll start here. We'll start with 15 degrees. It's written here for you. I want to convert 15 degrees to radians. Right? What I need to do is I multiply by pi radians over 180 degrees. You always want your units to reduce. So if I want radians, I need to cancel out, or I need to reduce my degrees. So the degrees, one should be in the numerator, one should be in the denominator. So if you did this 180 divided by pi, not going to work. Okay, you need to do it pi radians, radians divided by degrees. That way the degrees reduce. Okay, let's see, can I reduce 15? Yeah, divide by 5, that gives me 3. Divide by 5, that gives me 36. Oh, I can divide even more. Divide by 3 gives me 1. Divide by 3 gives me 12. So 1 times pi is pi. 1 times 12 is 12. The degrees reduced, so I'm just left with radians. So 15 degrees is pi over 12 radians. Let's do 8 pi over 3 radians. So 8 pi over 3, and this is radians. Now, once again, I want to convert radians to degrees now. I should have my radians in the denominator, right? So I can reduce them. So instead of multiplying by pi over 180, I'm going to multiply by 180 over pi, because it's pi radians. So now the radians reduce, so I'm left with just degrees, which is what I want. The pi's reduce. 3 reduces to 1, right? Divide by 3, here we get 60. So then 8 times 60 is 480 degrees, right? 1 times 1 is just 1. So this is 480 degrees. All right, so let's practice some more. This is extremely important. Okay, you need to be able to convert from degrees to radians and radians to degrees, especially if you don't understand radians, just like if it takes you a while. All right, like I said, we're working with radians the rest of the time. The definition isn't super important, but being able to convert and memorizing these ones, you don't need to memorize them, you can convert, but trying to memorize these will help out tons. All right, now I know there's some of you that are, this is going in one ear, out the other. All right, hopefully you just looked up. If that's you, please don't let that be you. Okay, this will be hard for you if you don't pay attention, or if you don't at least try. Okay. Oh crap! Sorry, I just realized I have a low battery. Let me go get my charger real quick. Okay. There we go. All right. So let's practice converting. We have 120 degrees here. Now you might say, well, how do I know when to convert from degrees to radians? If it has a degree symbol and it says convert it to radians. If it doesn't have a degree symbol, then it's radians, convert it to degrees. Okay. So I have 120 degrees. I want to get rid of the degrees and make it radians. So I'm going to divide. I'm going to have my degrees in the numerator. So I'm going to use this one over here. Pi radians over 180 degrees. The degrees reduce, so I'm left with just radians, which is what I want. Okay, let's see. I can divide 120 by 10. I get 12. Divide 180 by 10. I get 18. I can divide 12 by 6. I get 2. Divide 18 by 6, I get 3. So 2 times pi is 2 pi. 1 times 3 is 3. So 120 degrees is 2 pi over 3 radians. Okay. Negative pi over 12. And this is radians. So I want to get rid of the radians and have only degrees. So I'm converting. So my radians should be in the denominator. So I'm going to multiply by 180 degrees over pi radians. Sorry, it just dawned on me. I didn't tell you why we use that. 180 over pi and pi over 180, it says they're equal to each other. When we divide them, it equals 1. So if I multiply by it, I'm just multiplying by 1, which doesn't change my number, right? Anything times 1 is itself. So this stays the same. The only thing that changes is your angle measure, right? Your units of measure. So radians reduce. Pi reduces to 1. Pi reduces to 1. I can divide 12 by 6. I get 2. Divide by 180 by 6. I get 30. Divide 2 by 2, I get 1. Divide 30 by 2, I get 15. So negative 1 times 15 is negative 15. I have my degrees. 1 times 1 is 1. So negative 15 degrees. All right. 135 degrees. I'm going to multiply it by pi radians over 180 degrees. I want the degrees to reduce, so they're in the denominator. So the degrees reduce. I can divide this by 5. 135 divided by 5, that's 27. 180 divided by 5, that is 36. I can divide 27 by 3. I can divide 36 by 3, by 3, which gives me 9. I can divide 36 by 3, which gives me 12. I can divide 9 by 3, which gives me 3. I can do 12 by 3, which gives me 4. That's all I can do. So 3 times pi is 3 pi. 1 times 4 is 4. This is radians. So 3 pi over 4 radians. So 135 degrees is 3 pi over 4 radians. Now, so help me. If you write this as a decimal, wrong. Okay, I'm sorry. I know you can type in your calculator. It's wrong. Okay, radians, it needs to be left like this with your pi's. If you write it as in decimal, you're setting yourself up for failure for what we're doing next. All right, leave it in this format as a fraction. I know you don't like fractions. I've been telling you all year, we've got to practice, got to practice, got to practice, got to practice. You've been putting it off, and now it's hit you. All right, got to leave it like that. Let's see here. Negative 40 degrees. Once again, I want the degrees in the denominator so they can reduce. Divide negative 40 by 10, you get negative 10. Divide 180 by 10, you get 18. Divide 10 by 2, you get 5. Divide 18 by 2, you get 9. So negative 5 times pi is negative 5 pi. 1 times 9 is 9 radians. So negative 5 pi over 9 radians is what 40 degrees is. Let's do 5 pi over 4. 5 pi over 4. Okay, we want to reduce the radians, so we're going to put it in the denominator. So times 180 degrees over pi, radians. The pi's reduce to 1. Let's see. You can divide 4 by 4, which is 1, and 180 by 4, which is 45. 5 times 45 is, what is that? 225 over 1, which is just 225 degrees. So 5 pi over 4 is 225 degrees. Okay. Negative 6.28. Now this is radians, right? There's no degrees. This is radians. So I'm going to multiply. I want the radians to reduce. Multiply by 180 degrees over pi. Now notice the pi's, there's nothing reduces here with pi's. Just the radians, just the angle measure reduces. So this is equal, this angle in degrees is negative 6.28 times 180 over pi degrees. It doesn't come out all nicely. Sorry, I forgot my calculator. Now that degree measure doesn't make a whole lot of sense, obviously. So if you want it to make sense, plug it in the calculator. Negative 6.28 times 180 divide by pi. Where's pi? There it is. It's about, that's really close. It's approximately negative 359.8 degrees. So almost 360 degrees, but not quite. Okay, the reason for that is because negative 6.28, if you do 2 times pi in your calculator, notice pi to 2 decimal places is 6.28. But pi goes on for forever. It's an infinite decimal. That's why it's not quite 360, is because it's not quite 2 pi. Okay. Let's do the next one, 5. Now, once again, there's no degree symbol. Okay, no degree symbol. So it's radians. So 5 radians. We want to reduce the radians. We want to get rid of the radians. So we're going to divide by pi radians so that the radians reduce. Multiply by 180 degrees over pi radians. So the radians reduce. Once again, there's no pi here to reduce. So we just multiply straight across because we have a fraction, right? 180 times 5 is 0. 0 is 900 degrees, or 900 over pi degrees. Now, once again, if you want that to make a little bit more sense as a decimal, you do 900, you divide it by pi. It's approximately 286.5 degrees. Okay, 286.5 degrees approximately. The last one here, negative 500 degrees. We're going to convert to radians. So negative 500 degrees. We want to reduce the degrees, so we're going to multiply by this one. We want the degrees in the denominator, so multiply by pi radians over 180 degrees. The degrees, they reduce. I can divide negative 500 by 10. I get 50, negative 50. I can divide 180 by 10, which is just 18. That's all you can do. Multiply straight across. 50 times pi is 50 pi. 1 times 18 is 18. So 50 pi over 18 radians. And that's your answer. Okay. Now, I know a lot of you skip over the practice problems and then try and just do the quiz review. I'm begging you, do the practice problems here. Okay, even if this seems simple right now, it's brand new stuff for almost all of you. It's a new style of angle measure, of measuring angles that you're not used to, that you've never done before, right? And so when something is new and you want to get good at it, especially in quarter 3 where things are going to go quickly and you're going to need to be good at radians, but you're not going to have me every day and you're going to have to self-motivate, this is extremely important. You need to practice it a lot, all right? Our next standard, the unit circle, we're going to make you memorize, right? The calculus teachers, right, so Ms. Nelson and Mr. Olson, the trigonometry part, or these angles, the radian measures that are so important to calculus, or just after this class, anywhere you go in math, that they need to, you need to know them as well as your times tables. Okay, now I know a lot of you are like, oh, I don't know my times table. No, okay, you know them, right? It might take you a second. It's not like that. It's okay. It can take you a couple seconds. But do you know what 3 pi over 2 is just off the top of your head? Without, okay, well, I gave you a nice one, right? I mean, do you know what 5 pi over 4 is just off the top of your head? Okay, that's something you're going to need to know. Or at least be able to do it quickly in your head. Can you do, 20 pi over 6? Right, you need to know how many times you go around the circle for that. And what you come back to. Right? So it's really important that you practice radians right now. Get used to this. Because that's all you're going to see from here on out. All right? That's it for the video. As always, let me know if there's anything I can do to help you out. I'm here every day after school until 3. That's it.